Hello. Welcome to the next playlist on my YouTube channel. In the previous playlist, we built our own interpreter, and now I'll be building my own debugger from scratch in Rust. And the only reason I choose Rust is because I hate C and C++. Anyways, debuggers are a category of software that are pretty close to the underlying architecture of your system, and they also depend on the compiler being used, the compiler that was used to generate the binary you want to debug, and the target processes we are trying to debug. So it will depend on the kind of binary that you're trying to debug. And so the code we write in this series will not work on Windows or Mac OS. What we are doing is I'll be writing code specifically for Linux. So if you have a Windows machine, I would recommend using WSL. I'll be using WSL myself, and I'll show you how you can set up your WSL for this project. We will focus on compilers that compile down the code to binary code, like the Rust compiler or the C compilers, not the Java and C Sharp compilers. The goal of the debugger is to figure out which line in the source code corresponds to the binary code being executed. That information is not included in the compiled executable. We also want the variables to reflect different values at different lines. Compilers produce that information, but not as part of the release build. All that metadata is part of the build when we use the compiler with debug options. And so we will need to understand the format of the debug information and the structure of the produced binary. Since the format of the debug information also varies from debugger to debugger and platform to platform, our code unfortunately will not be very portable at all. The debug information can tell us what compiler was used to generate the binary, what all files in the file system were used while compiling, the names of the defined functions, where they will be loaded into the memory, and when we execute the code, names of variables, etc. So debuggers have the ability to intervene with the execution of the process, and we will be using Linux syscalls for that. And since we will be using Linux syscalls, I found a helpful crate called the Nix crate. This will let us use syscalls like ptrace and other as well. What's the error? Let me fix this. Sorry. And since we will be writing a code for Linux, but since I am on Windows, maybe a lot of you are too, I would recommend creating this .cargo file in your Rust project, .cargo directory, and create a cargo.toml right here. And in here you can give a build target for Linux. So this will build your project only for Linux. This is also required because Nix doesn't work on Windows. Without this build target, your JetBrains IDE or whatever IDE you are using or whatever Rust analyzer you are using will not be able to pick up the fact that we are actually trying to build for Linux, and so it will throw errors on Nix. So I don't want my IDE to do that. I will not be building from here. Maybe I will, I'm not sure, but I will primarily be building from WSL. And from WSL, I think it should cargo build. Yeah. Yeah. So for WSL, it will work fine. Uh, this package will work in WSL, but it may not work on Windows. That's why I just want my IDE to know that I'm building for Linux, and I will be using a WSL to do that. I will not be building through the IDE or something like, or not from the Windows. Anyways, uh, I told you that we will be using Linux syscalls to do that. Now the syscalls, I hope you know what syscalls are. Syscalls allow you to interact with other processes. It allows you to create new processes with fork and start new processes with exec, replace the current process, etc. There are a lot of syscalls, and we will be going through them as required. One syscall that I've already showed you is this ptrace. Ptrace is a very useful syscall. The API is not very pleasant to work with, but it's very useful nonetheless. Uh, ptrace allows you to interact with other processes, to interact with the RAM of other processes, and a lot of other things actually. But this ptrace doesn't exist on Windows, right? I told you we'll be building for Linux. So you can maybe port over the code to Windows. I do not plan to do that. It will require some research on your part, but I leave that up to you. It's up to your discretion. Let me show you what all ptrace can do. Let me show you some of my notes for this. So ptrace is used primarily for debugging on Linux. It allows you to read memory from other processes from the given address, and it allows you to set up new processes. What I mean is you can use ptrace attach to existing processes, and ptrace continue a process that has been blocked previously. Anyways, to set up your WSL, I have some steps that you can follow to set up Rust and Cargo on WSL. This is all that you need for this project. Run WSL on your Windows machine, and then sudo apt update, download and run Rust up. Source the environment to update the environment variables, and then you will be able to see the Rust compiler and Cargo. But to be able to run a Cargo, you also need the C utilities, and you can get that with this command. After this, your Cargo build command should work. So right now this project is bare bones. It's a bare bones Rust project. All I'm doing is printing hello world. All right. I just have a utils folder created, a folder for tests, and a folder that will be I will keep other required things for the debugger here, like the breakpoints, etc. We'll come to that soon. Anyways, it's a very bare bones Rust project. There is nothing in it right now. I'll show you the cargo. Yeah, I showed you that. Just one dependency right now. We'll maybe add few later, but that's it. It's a very bare bones empty project. And from the next video, we'll probably be writing code. We'll start coding. Now, full disclaimer, this is not my invention. I found a lot of resources online. I read through them and I decided to write my own debugger in Rust instead. Primarily because I wanted to learn Rust. And in the name of disclaimer, this was the primary resource that I used to learn about debuggers. This book, and I highly recommend you get this book too. Anyways, this book is all the code in this book is in C++. Uh, but I will be writing everything in Rust. And since you are watching this video, I assume you are interested in knowing how debuggers work. So I would highly recommend going through the following videos just for fun. These are videos by Ryan Fleary. I guess that's how you pronounce his name. Uh, the videos I'm talking about are designing a UI system, UI for debuggers, debuggers and programming from scratch with Ryan Fleary, how to architect large software projects, cracking the code, real-time debugger visualization architecture by Ryan Fleary, and what are arenas. That's very interesting video. Anyways, I guess that's it. That's it for an introduction in this video. In the next video, we'll be writing some code. See you in the next one.